Hello, my name is John Ormond, and I'm a Principal Program Manager on the Azure Networking team. And today I'd like to talk about building secure networks inside of Azure, also how to connect your hybrid network to that secure network in Azure. So most of the things that I will be talking about today are in the networking area, which is on the bottom right corner of this slide. Specifically, I'll be talking about software-defined networking related to virtual networks, ExpressRoute, load balancers, VPN gateways, as well as network security groups and user-defined routing, which aren't on this slide, but are also inside that the networking section represented on the slide. But first, I'd like to talk about what a DMZ actually is, and not as it relates to Azure, but more generically, just in any corporate traditional on-premise network. A DMZ, or demilitarized zone, is a place that divides networks of different levels of trust. So it's usually either a physical or logical network that is multi-layered. Quite often there will be, for instance, 3 different layers where you have an untrusted network, a semi-trusted network, and then the protected back-end network. And generally this is to protect a network from the internet and a corporate network, something along those lines. There can be lots of different technologies used at the boundaries of your DMZ. There's also usually auditing and inspection and security policy at each boundary or security layer of your DMZ, and even more deeper in your network between your corporate network and Azure. So if we look at what that looks like, you can see here just a very high-level example of what a corporate DMZ may look like, where you've got internet traffic coming in, hitting that first boundary of either firewalls or load balancers or different technologies that can be used to inspect that traffic to get to that web server that lives in that front-end LAN. And then another boundary on the back-end side that, again, could be the same technology, different technology, firewalls, load balancers, whatever you want to, whatever you need for your specific example, that can reach inside that protected network to get just this very specific data. But you'll also notice that there could be branch offices that come in through that same boundary, and that traffic may be allowed to go to the back end. It's important to note that it doesn't bypass any of the security, but it's recognized as being authorized and valid, and so it's allowed to pass deeper into your network. Now, there are many, many ways to define the DMZ or the security boundaries, technology, devices, 1 layer, 2 layer, N layers. And it really just depends on what your specific needs are as to how you're going to build out a DMZ for your specific use case. So now with that kind of out of the way, let's switch back to Azure, and I'll discuss a couple key features that relate to network and network security. The first and most primary would be Azure Virtual Networks. That is the primary, I guess, virtual construct on which all your workloads are connected, most of the security policy and features are attached to. So everything really revolves around that Azure Virtual Network. By default, these networks are isolated. So even if you have 2 virtual networks in the same subscription, they can't talk to each other. Only what you allow in and out of that network is what's allowed. So that's a very powerful feature, and it allows you to set up multi-tiered networks. Now, inside that virtual network, you can also have subnets, which are a further subdivision. By default, those subnets can talk to each other. But again, we can use some of these features to control how that traffic is routed and flows. So with that, then the next feature is a network security group. And a network security group really is a group. It's a collection of rules. It's a rule set, kind of like ACLs, that can be applied at many different levels. So you can take a specific grouping of rules and apply it to just a single NIC interface on a VM, on a subnet, or on the entire network itself. And it really depends on the granularity that you need to satisfy your security requirements on how many rules the rule set has and where you apply it, if it's at the VM or at the bigger virtual network level. Next, we've got user-defined routing. And this allows us more than just ACLs, but to actually define the path that our network traffic is going to take by changing the next hop. So normally traffic outbound would just go from Azure's edge to the internet. With user-defined routing and a companion feature called IP forwarding, you can actually tell the backend subnet to not go directly to the internet, but instead go to my firewall or my virtual appliance. And this will allow you to route traffic outbound in a way that you can audit, inspect, filter, or whatever your security devices, whatever features they have, will allow you to apply that to the traffic even outbound or inbound. So it can allow for very robust feature sets on your DMZ. After that, I did talk about a firewall. So with the advent of multiple NICs for VMs, I guess about a year ago, we've now seen an explosion of network virtual appliances in Azure. So we've got a lot of different vendors, routers from Cisco, load balancers from F5, firewalls from Checkpoint, Barracuda, Fortinet, are all now forming a very robust ecosystem of partners providing these virtual appliances that can do a lot of the advanced security that you can do on-prem. So most of the things you can do on premises now are becoming available in Azure through these technologies. Most of these devices are available either in the Azure Marketplace or in the VM image gallery. And you can use those in combination with the other features to build a really, really robust security network or secure network. So if we want to look at this from the internet side, there's also some native Azure platform capabilities that can really help with your security stance. So if we look at a packet coming in from the internet on the right-hand side of this slide, it first would hit the Azure platform's DDoS protection, which is a robust mesh of basically DDoS protection, that if a DOS attack is happening, a specific IP will be attacked, and this DDoS protection will black hole, basically null route that traffic. So that specific endpoint will potentially go offline, but the services around it are still up and they're not affected by that attack. So it's not protecting the attacked property so much as it is everyone around it. So if you have a noisy neighbor, you're not going to be affected by that. And if you have good resiliency strategies with your security, even if your service is taken offline, you can switch to a different endpoint, and now your service can be up and running with that. But this is something that's not user configurable, but it's an important part of the Azure platform, and it's securing all of our tenants, as opposed to everybody have to do their own DDoS protection. Once your packet gets past the DDoS, now you're into the service endpoints. And this is a place that is user configurable, that you can allow exactly what traffic and only the traffic that you want, usually by IP on where you want it to go and which ports and protocols you'd like to allow in. So by default, nothing is allowed unless you open it up. When you create a VM, for instance, a Windows VM, by default PowerShell and Remote Desktop will be open, but you can take those off and add others or whatever you want to do to just allow the traffic that you need to come in to come in. Once it makes it past the endpoint, you've now reached the Azure Virtual Network. Again, that's the central point, the foundation of the rest of the user configurable security items. And then at that point, the user-defined routing, the security groups come into play, and also the virtual network appliances. So if a packet gets through all of that stuff, it's usually a good chance that it's going to be a valid traffic. So when we add all of that together and we tack on, say, our corporate network, it can look something like this. Again, this is very high level, a couple slides. I'm actually going to give a little more detailed example. But with this, you can kind of see how the layers start to form. You've got the internet traffic, again, coming through that front-end boundary and then moving into the front-end subnet where the web server will accept that traffic. Now, the internet traffic actually stops there. It's not allowed any deeper. And in fact, usually that front-end DMZ will be some sort of a NAT or reverse proxy that will stop the internet traffic and actually turn it into an internal session when it talks to the web server. And then the web server has very specific and narrow rules that allow it to talk to that back-end subnet where, say, an application server may reside or data source may reside. And then there's a further layer of protection between the corporate network and the Azure network that can provide additional levels of security. Now, quite often, there will be different policies, different devices, different technologies used at every boundary. So it's going to be a little bit different depending on the specific needs and the sensitivity of the data. The hope would be that if an attacker was to bypass the front end and, say, get access to your web application somehow, that there would be very little sensitive corporate data on that device, as little as practical. and that they couldn't take another step further into the network without compromising different types of security. So we really want to have security in depth across the different boundaries and stop attackers in multiple ways. So, and again, a few slides I'll show you how that works. So with that said, let's look at a few examples of some DMZs. And these are going to be very simple, just for illustrative purposes. I generally would recommend a lot more complexity to your design, which has some drawbacks, but we'll talk about that. But in this model, we're using just network security groups and a virtual firewall, or a virtual network appliance that in this case could be a firewall. With this example, let's say that a hacker was trying to get to the SQL server on the backend network. They would generally come in on port 1433, which is the SQL port. You shouldn't have that port open because the only thing this app should be doing is sending web traffic, which is port 80 or 443. But for some reason, let's say that was accidentally left open as an endpoint, the hacker would be able to get to the firewall. Well, the firewall shouldn't have a rule that would pass that traffic from the internet to your SQL server, so it should be stopped there as well. And then third, the network security group should not allow internet traffic into the backend. So you've actually got 3 different layers protecting you from an attacker trying to get to that SQL backend server. Now, just as important as blocking traffic, so is allowing traffic. So we would want to have, say, port 80 for our web server to be able to come in through that service endpoint, reach the firewall, have that directed to the web server, and then the web server, not the internet conversation, but the web server should be able to make a call through the security groups back to that backend server, SQL server, that can then respond. So we need to make sure that we're scoped down as restrictive as possible. We are poking holes through our isolation layers, so it's really important that those holes are as small and specific as possible because we don't want to give attackers a bigger attack surface. So that's really important. So one of the things that we also want to talk about is who has access to both the security policy and the servers and the application. Hopefully you've heard of segregation of duties. That's a really important concept in that you want to make sure that the folks setting security policy are different than the people who are server admins or application administrators. And that helps protect against nefarious internal activity, but even more importantly, quite often when troubleshooting, you may remove a security rule or something of that nature that will allow the traffic to pass through easily to diagnose a web issue. But if it's one person, they may be troubleshooting and forget to put that ACL back into place. And inadvertently, completely by accident, leave a hole open that can be exploited later by an attacker. So it's really important to keep those duties segregated. And hopefully by having at least 2 or more groups involved, you'll avoid simple mistakes like that, which quite often can happen and leave risks that you're just completely unaware of. With that, let's take a little more complicated look. This adds user-defined routing. And we still have a firewall and we still have network security groups, but we've added a 3rd subnet. So in this example, we've got a security network on the top and then a front-end network and a back-end network. Similar type of app where there's a web server and SQL servers, but with user-defined routing, you can see there's a little table at the top of each of the back-end and front-end subnets that have the next hop defined as the firewall. So with this, any traffic leaving the back-end or the front-end subnet will actually take that next hop up to the firewall. And then the firewall can decide, or whatever kind of virtual appliance you have there, can decide if that traffic should be allowed in or out of your environment. Now that's really nice because now you can do not just port and IP control, but also if your security device allows for it, URL reputation or URL filtering or behavior analysis, virus signature analysis. You can start to do more of that advanced security features. Another really good part of this is you're going to get logging and auditing abilities on outbound traffic as well as inbound. So this is something that can really increase your security stance, and for sensitive data is approaching a design that I would recommend over to the other, which was simply just inbound. Now, this does become more complex, and that's a good thing and a bad thing. So it's good because you can have a more robust security stance, but now troubleshooting can become more complex. As the rules grow on your firewall and the network security groups and the routes grow in your routing table, if there is an issue or traffic isn't flowing as you expect it, maintaining this over time can really become burdensome. So I recommend using as few boundaries as possible, but you have to balance that with how secure are you? What are your security requirements? Because obviously you can't have too few boundaries or you'll expose yourself to greater risk. So finding that boundary or that balance between complexity and simplicity and supportability is super duper important. So with that, let's look at some PowerShell scripts and some code about how to actually implement network security groups and user-defined routing. So this is a very, very simple script. This is also using kind of the older version of PowerShell, the service management version. There is a newer ARM or Azure Resource Manager templates that we could use to deploy this. For illustrative purposes, I'm going to go through the older scripts, but there are other sessions that you can look at to see the ARM templates. Also, this whole session is based on a document that has the detailed scripts in it as well. But for network security groups, you can see the top line is creating the actual group. So the first thing we do is create the group, which is a container. The red text with the $sign in front of it are variables. I tend to, with my PowerShell script, use variables for everything. And that way I can have one section to set names and things of that nature, things that change often. And I can reuse this script over and over again. So the first part is creating the group itself. And then the second section, we need to add a rule. Now in this case, it's probably more simple than you would actually use in a production scenario. You're going to have multiple rules. But to keep this example simple, I just put a deny rule in here. So in this case, we're going to you can see the first statement is to get the Azure Network Security Group, the one I just created, and then we pipe that into the set Azure Network Security role. We name it, and then we say, is this for inbound traffic or outbound traffic? For this, it's inbound. And what do we want to do with it? Do we want to allow or deny? In this case, it's to deny. And then we say, what are the source addresses that we want this rule to apply to? There are some default names, and I've used two of them here. The first one is internet. So the VNet knows what is local address, and then anything else is the internet. So anything coming in from an unknown source or the internet would apply to this. We say the source port range is an asterisk, and that is basically meaning any range. So any port, doesn't matter what it is, this will apply to. And then it says, where's that traffic going to? I used another variable, virtual network. This is defined by the definition of your virtual network. So whatever IP address ranges you've defined your virtual network with, that's what this represents. And these internet and virtual network is not something that you have to set. It's automatically a default there by the system provided to you to use. So anything from the internet going to a virtual network on any port and going to any port, and then also protocol is an asterisk, so on any protocol will be denied. Now, we're not going to apply this to our very front-end security network, just to the back-end network. So what we want to happen is any internet traffic going directly to the back-end or front-end, we want to deny. It should all be going to that virtual firewall on our security network before it goes to there, and then it gets routed from that security device to our front-end and back-end networks. So this is a second layer of security because, again, if we did good endpoint management, there are no open endpoints to the front-end or back-end, but this adds another layer of security in case somebody makes a mistake, fat finger, or whatnot. Then the last step on here is we need to bind that security group to a subnet, a NIC, or the whole VNet, depending on what we need to apply to. In this case, I'm going to apply the group to the front end and the back end. So you see two statements here: set Azure Networking Security Group to subnet, and then I give it the names and the subnet and the VNet name, and this applies that group to, in this case, the subnet. Really important to remember to do the binding part. If you don't associate it, you just create the group. I've seen a lot of issues where people say, hey, my security group doesn't work. Well, that's because you made the group, you added rules, but you didn't bind it to anything. So if you don't attach it to a subnet or something, that rule set is not going to apply. So make sure that you always do the last two steps, or the last step, which is to bind it to something. Make that rule apply to something. Now, with user-defined routing, similar set of steps in that first we create a route table. Again, this is just the container for the routes. And then we add route rules to it. In this case, I've added the rule that sends all traffic to the firewall. So we give it a name, we give it an address prefix, in this case 0.0.0.0/0, which means basically any IP address that's going out of this subnet, we want to route somewhere. And then the next two arguments are what we tell it where to route to. The next hop type in this case is a virtual appliance. Remember that firewall. For a virtual appliance, you have to give it an IP address, which I put the firewall's IP address. There are a couple other types of next hops that you can do that don't require an IP, but for a virtual appliance, we have to apply the IP. Again, this is super simple. Normally, we'd have a few more rules in here. In the paper that this talk is based on, it shows the rest of the rules that you would put into a good UDR route table. Once your table's built, again, at the end, you need to attach it to something. A route table just in and of itself doesn't do anything. Once it's associated with a subnet or a VNet, then it can actually take effect. So the last statement there actually assigns it to the subnet on my virtual network, and just by calling the name of that table. This will usually take about a minute to take effect after you've run the command, and then the routing table is in effect, and the routes out of that subnet will now follow that path that you've assigned to it. So this is a pretty good way to add complexity and routing to your network design that can really give you the auditing, the logging, the capabilities that you'll need to really lock down a network appropriately. So one of the things I talked about earlier was the hybrid connection. How do I take my Azure, now that I've got a good DMZ in Azure, how do I take that back and connect it with my corporate network? And I'll talk about ExpressRoute. So in this example, I've taken the very first example that we looked at with firewall and network security group. And then down on the bottom right, you can see there's our on-premise corporate network coming in through an ExpressRoute connection. So talk a little bit about ExpressRoute. I'm on the ExpressRoute team, so I'm a little biased. It's one of my personally favorite features in Azure. But this allows us to actually connect our corporate network to Azure, not using the internet. So with ExpressRoute, you actually take circuits from your service provider, whoever provides your internet, hopefully has private connectivity with Azure. We're working with multiple telcos around the world, adding more every month. And with that, you can actually get a private connection from your telco that connects your on-premise network through their network directly to Azure. So your traffic never hits the internet. Now, that will give performance and security benefits, but also now you can get an SLA from your service provider on that traffic, on the uptime that you just can't get with the open internet. So that's one of the reasons that I really like ExpressRoute as a connectivity model to my cloud. Another really nice feature is it's all BGP connected, so it's not a VPN, which means that the address space in Azure is a part of your corporate address space. So if your corporate network was, say, 10./8, where you had all the 10 space, if you carved out a chunk of that, say a 16 or a 24, and put it into Azure, that traffic is now directly routable to Azure and back to your corporate network. So you've really just extended your corporate network directly into the cloud. So that allows really robust connectivity between the two networks because they're now basically one contiguous network. But now you've got another boundary. And so this is another place that we can look at to say, what type of security do I need there? Do I trust the backend network in Azure? Do I want to put another firewall in place? Do I want to put other security monitoring devices? This also gives us the opportunity to put security devices on-prem or in the cloud, either way, depending on your specific needs. But ExpressRoute or site-to-site networking VPNs can be used as well. But again, I'm partial to ExpressRoute. But it's a really good way to lead, to give you a hybrid connection between your corporate network and your Azure network. So let's kind of look at some of the takeaways. So the things that I've talked about when I approach a new situation and I start to think about network boundaries, I'm always looking at three kind of top-level questions. And that was, how many boundaries do I need? Where are all the logical places that I need to insert security policy? And then where should those be located? As I said, if you have a hybrid connection, some of them have to be in Azure, but you do have some options to put it on your on-prem as well. And then finally, how are you going to implement these boundaries? What technologies, what devices do you want to use? So we've talked a little bit about some of these best practices that I have down below, segregation of duties. Number two, I don't think we've talked about, so that's something that's really important is don't make monolithic decisions about your security. If you've got a security and risk team, a server team, an applications team, a support team, involve as many people as you can when defining what your risk profile is going to look like. Having one group tends to sway things one way or the other, and it's important to get your business involved, your tech people involved, to really make a good decision on what the appropriate risk stance is and what your willingness is to take on complexity versus operational and troubleshooting ease. So that finding that balance is super important. Again, use the smallest number of boundaries possible, but don't go too small. The balance there is key. Limit your holes in your boundaries to as small as possible. Again, use ExpressRoute. That keeps your traffic off of the internet and gives you those SLAs. And something that is often missed now that we're moving into a cloud world is not all security has to be at the network layer. So if you think about the ISO stack, think above layer 4 because your workloads may be on-prem today and in the cloud tomorrow. Is that going to require a physical change of your network? Or could you use Azure Active Directory or things higher up the stack on that OSI model to protect your workloads in a different way so that you're not as heavily dependent on the network? So it's really important to consider mobility as you're applying security to this. And then finally, review your security logs. Quite often we see people that look at their security logs only after an event has taken place. And if you've got a good security team with the right tools, that's as important as any of the features and devices that you use in your security boundaries, is to make sure that you're looking at your logs and see if you can find your attacker knocking on the door before they break it down. And with that security in depth, segregation of duty, that you can actually make a really robust security environment in Azure and between your on-premise and Azure networks. So I've expressed just a lot of ideas over the last few minutes. And if you need more information, this is a slide where you can get very detailed information on virtual network security groups, ExpressRoute, user-defined routing, etc. The bottom link is the link to the security paper that this talk was designed around. It's got a high-level view with all of the examples that you've seen today and links to the very detailed code, both the legacy Azure PowerShell scripts and the new ARM template models. So I would recommend, if you're interested, to check those out. With that, I thank you for your time and your interest in Azure Virtual Networking and security. Thank you.